Examples and observations. We write the natural numbers 1, 2, 3, 4, 5 in a particular order. We can easily identify the position of any number in this order. Also, the number at each position in this order is greater than the previous number by 1. This is a sequence of numbers. 1, 4, 9, 16, 25, 36 is a sequence of perfect square numbers. Now in the above examples, sets of numbers are arranged in specific orders. A set of numbers arranged in a definite order is called a sequence. For example, 1, 8, 27, 64, 125, etc. is a sequence of cubes of natural numbers. Therefore, we can clearly identify the next terms in this sequence. Now let us consider another example. 5, 11, 2, 19, 8. Here, 11 minus 5 is equal to 6, 2 minus 11 is equal to minus 9, 19 minus 2 is equal to 17, 8 minus 19 is equal to minus 11. Hence, the difference between the consecutive terms is not constant. 11 upon 5 is not equal to 2 upon 11, is not equal to 19 upon 2, is not equal to 8 upon 19. The ratio of any two consecutive terms is not constant either. There is no other pattern or rule that applies to these terms. So, this set of numbers cannot be called a sequence. Terms in a sequence. A specific number is written at a specific position in a sequence. The number in the first position in the sequence is written as A1, the number in the second position as A2, the number in the third position is A3, and so on. In this way, AN will be in the nth place in this sequence with n terms. In other words, AN is a sequence of n numbers, A1, A2, A3. These are the terms of the sequence, and AN is the nth term of the sequence. A sequence is represented with the help of English alphabets in small case. It can either be written as a list F1, F2, F3, T1, T2, T3 or S1, S2, S3, S4 or so on. It can be shown using parentheses as Fn, Sn. Now look at the following set of numbers. 2, 11, minus 4, 0, 5, minus 3, 8, 12, 61. This set of numbers is a sequence, but we do not know exactly why the numbers are in that order or how they are connected. Generally, we study only those sequences in which the next term can be determined by a clear rule or a pattern. Now, let's study some special examples of sequences. 3, 7, 11, 15, 19, 1, 0.5, 0.25, 0.125, 0.0625. Now, when studying the above examples, it is seen that in the first example, if we add 4 to a term, we get the next term, which means that the difference between any two consecutive terms is constant. In fact, it is 4. In the second example, multiplying a term by 0.5 gives the next term. That is, each term is 0.5 times its previous term. In the first example, each new term is obtained by adding the fixed number to the previous term, while in the second example, each new term is obtained by multiplying the previous term by a fixed number. The first sequence is called an arithmetic progression, while the second sequence is called a geometric progression. In this lesson, we'll learn about arithmetic progression, a sequence in which each term is obtained by adding a particular number or difference to the previous term is called an arithmetic progression. If the difference between any two consecutive terms is always the same, that is constant, then that difference is called the common difference or constant difference. This difference is denoted by the letter D. Let us denote the first term in the given arithmetic sequence by the letter A. For example, 5, 8, 11, 14, 17. Here, the first term A is 5. Difference between the first and the second terms, so second term minus first term, that is 8 minus 5 is equal to 3. Third term minus second term, that is 11 minus 8 is equal to 3. Fourth term minus third term, that is 14 minus 11 is equal to 3. Therefore, the common difference here, that is D, is equal to 8 minus 5, that is 3. Hence, next term is equal to previous term positive 3 can be stated as a rule for this progression. From the above example, it is seen that first term, that is A1, is equal to 5. Second term is equal to A2 is equal to A1 plus 3. Now this is equation 1. Third term is equal to A3 is equal to A2 plus 3 is equal to A1 plus 3 from equation 1. A2 plus 2 into 3 is equal to A1 plus 2 into D. 3 is the common difference. So we can write the third term as A3 is equal to A1 plus 2D from equation 2. Fourth term is equal to A4 is equal to A3 plus 3 is equal to A3 plus D is equal to A1 plus 2D plus D from equation 2. A4 is equal to A1 plus 3D from equation 3. On examining equations 1, 2 and 3, we can say that the nth term is An is equal to A1 plus n minus 1 into D. Formula for the common difference of an arithmetic progression. Suppose Tn is an arithmetic sequence and T1, T2, T3, T4, Tn minus 1, Tn are the terms of the sequence. Tn is the nth term in this sequence. Common difference is equal to D is equal to T2 minus T1 is equal to T3 minus T2 is equal to T4 minus T3 is equal to Tn minus T into n minus 1. The constant difference between two consecutive terms of an arithmetic sequence is called the common difference. It is denoted by the letter D. Now let Tn and Tn plus 1 be the last two terms. Then the formula for the common difference is D is equal to T into n plus 1 minus Tn. Examples: 4, 7, 10, 13, 16. First term is equal to A is equal to 4. Subtract each previous term from the subsequent term. 7 minus 4 is equal to 3. 10 minus 7 is equal to 3. 16 minus 13 is equal to 3. Therefore, common difference, that is D, is equal to 3. Now, given the first term A and the common difference D of an arithmetic progression, let's see how to find the next four terms. Suppose the first term of an arithmetic progression is 4 and the common difference is minus 3 upon 2. Find the first four terms of this arithmetic progression. Solution: A is equal to 4, D is equal to minus 3 upon 2. Therefore, first term is equal to 4. Second term is equal to 4 plus minus 3 upon 2 is equal to 5 upon 2. Third term is equal to 5 upon 2 plus minus 3 upon 2 is equal to 1. Fourth term is equal to 1 plus minus 3 upon 2 is equal to minus 1 upon 2. So, these are the first four terms of the given arithmetic progression. What did we learn? A sequence is a set of numbers arranged in a specific order. Natural numbers, even numbers, odd numbers, square numbers, and cubic numbers are some examples of sequences. All set of numbers are not necessarily sequences. That is, not every collection of numbers follows a rule. A set of numbers becomes a sequence if each consecutive term can be found using a specific rule. A sequence in which each term is obtained by adding a constant number to the previous term is called an arithmetic progression. This constant number is called the common difference between the numbers in the series and is denoted by the letter D. The formula for the common difference of numbers in an arithmetic progression is D is equal to Tn plus 1 minus Tn. Given the first term of an arithmetic progression and a constant difference, the nth term is An is equal to A1 plus n minus 1 into D. Exercise. Identify whether the following sets are sequences: 4, 8, 12, 16, 2, 2, 2, 2, 2. Which of the following are arithmetic progressions? Minus 1 upon 4, minus 1 upon 2, minus 3 upon 4, minus 1, minus 5 upon 4. 1, 4, 9, 16, 25. Find the first term A and the common difference D of each of the following series. Minus 5 upon 2, minus 2, minus 3 upon 2, minus 1, minus 1 upon 2, minus 5, minus 9, minus 13, minus 17. Find the next four terms of the following arithmetic progression: 11 upon 4, 19 upon 8, 27 upon 16, 35 upon 32. Square root 2, square root of 2 plus 3, square root 2 plus 6, square root 2 plus 9.